Welcome to the next session where we're going to start looking at, you're going to be asked to sketch various graphs, okay? There's going to be 4 that we're going to do, but we'll start with the straight line first. When they say sketch, essentially the recipe is going to be the same. It's not going to change at all. They're going to give you a function or a graph and ask you either sketch it or determine the equation of the graph or the function, right? So we're going to be given, they might tell us that we've got a straight line joining 2 points, work out the equation of the graph, or they might give us a graph showing the 2 points and say that, or they might say this is the equation, draw the graph. Let us first of all start off by looking at something where they say to us, all right, let us say first of all, let's say they want us to sketch, and they're going to say sketch the graph. Now, just a word of caution here, okay? Please, when you're going to do these things, it's not expected to take out graph paper and they want you to plot the salient points. In other words, they want to see, can you work out the gradient or the shape of the graph? They want you to work out where it cuts the y and where it cuts the x-axis and join those up in a smooth curve. That's essentially what they're after here. It's not about sketching it accurately on graph paper. Obviously, you try and scale it so that it looks about right, okay? And no, they're not going to give you numbers of minus 26, 152, because that's kind of off the scale, and you can do the same thing with normal graphs in a range that we can work with on a piece of A4 paper. Let us say they say this, sketch the graph of y equals, and here they've said minus 4 minus 3x. Okay. Step 1 is the standard form. Okay. I prefer it. I like it. Let's keep with the standard form. What we say is this is what we're given. Y is equal to minus 4 minus 3x. The standard form is it's a straight line, is mx plus c. So what do we do next? We rearrange. We rearrange the terms so that it looks like the standard form, right? Because once it's in the standard form, we can then very quickly even read off a lot of the points. So let us put it as to y is going to be equal to, in this case, minus 3x minus 4. Can you see, therefore, m is equal to minus 3 and c is equal to minus 4? Okay? That's what we get from that. Let's just recap it. There we go. There's my gradient, m, and there's my c value. That corresponds to that, and that corresponds to that. Now, the next step with this is to say, okay, therefore, the shape m is less than 0, means m is negative, which means it's going to slope that way, right? What were our choices? If m was greater than 0, it's going to slope upwards, isn't it? Okay? Right. Now the next one. Okay? They say to us, okay, well, no, the next step is step 2. Let x equal 0 and work out y. Work out y. Please remember always here, guys, that x and y go together like whatever suits you. But if you've got an x, you can find a y. If you've got a y, you can find an x. Very, very important in all of these, okay? That you I know it's a simple concept, and I know you're probably saying, but we know that. I'm just saying that I'm reinforcing it so that you remember it, okay? Now, you say work out y. So let us put x equal to 0. Therefore, y is going to be minus 3 times 0. Okay, minus 4. Y is minus 4. Write down the coordinate 0 and minus 4. Okay. The next step, I'll do it this side. Okay. Let y equal 0. Therefore, 0 equals minus 3x minus 4, And then we say, therefore, x equals, it's going to be minus 4 over 3. Because the 4 goes to the other side, that's a simple equation to solve. Write down the coordinates, minus 4 over 3 and 0. Now, hey presto, what can we do? Now we can go and we can have a look and we can say, okie dokes, let's have a look. Now we plot the points, okay? Now, just as an idea, when you plot it, sort of gauge like maybe a centimeter is 1. So we say, all right, on mine I've got 1, 2, 3, 4, and minus 1, minus 2, minus 3, minus 4, and 1, 2, 3. Now we can plot our points. So we plot 0 and minus 4. So 0, okay, let's just label it x, y, arrow, arrow, origin, and this is minus 4. So that's the point there, 0, minus 4. And the next point is minus 4 over 3 and 0. Minus 4 over 3 and 0, let's say, is over there somewhere. Minus 4 over 3. Whoops. Minus 4 over 3. Okay. And 0 is over there. Then we're going to join the points. Okay. And granted, you would use a ruler to do it, to go through the points. Now we can check. Okay, we can check. Yes, it is sloping the correct way. Therefore, it's negative. Okay, you can always go back and double check your work and say, I've drawn the graph the right way. What do we call this? This is the Y-intercept. Right? This over here is the X-intercept. All right? There we've got the slope, and we've got everything that we need. Please note that you can read off from y equals mx plus c. C is the y-intercept straight away. Okay? Why? Because if I put x equal to 0, I get y equals m times 0 plus c. So y is going to be c. Right? So that's basically the way we're going to sketch. So when you're given any one of these, okay, you first just go through the steps. With all of the graphs, you're going to see the steps remain pretty constant, in fact, okay, that we're going to do. Now, I'm not going to do a lot of straight lines. We'll do a lot more of them in the exam prep and the test prep sections, right, where we can work it together and you've got something to work with. But I'm assuming that basically the straight lines actually are quite a simple one. They're not a difficult section to deal with. However, let's just quickly look at the effects of M and C. All right. What are we saying? We're saying if we change M, the gradient, the slope, what is happening to the graph? Does it get steeper or does it get flatter? And if we change C, the y-intercept, what happens to the graph? Now, essentially, right, one of the best ways of thinking about this is to just know your standard graphs, okay? The standard shapes. And that'll become a little clearer in a few moments as we move along with this. The effects of M and C. So we've got a standard form of graph is y is equal to mx plus c, right? As an aside, if you got 3y minus 2x equal to 6, okay, what would we do? We would rearrange it because it must look like y equals mx plus c. So we would then take the 2x to the other side and we'd say 3y is equal to 2x plus 6. Then y is going to be 2x plus 6 over 3, which is going to be 2/3 x plus 2. I just divided everything by 3. That is how you manipulate to standard form. And we're going to learn how to manipulate them all to standard form. Very, very critical part of the work. Okay. Now, let us have a look what happens if we change the gradient, all right? Now, for this, okay, let's put in our axes, our origin, etc. Now, I like to start off with an understanding of this is the line y equals x. Going at the other side, that is the line y equals minus x, okay? Those you did last year, but really you should easily be able to see that if I plot, for example, 4, y is minus 4 if x is 4, and y is 4 if x is 4. It's the simplest straight line of the lot. Now what we're going to say is that the gradient here, m, is equal to 1. M over here is equal to minus 1, right? Now, what if we make m bigger? Okay, let's logic it out here, right? M is equal to y2 minus y1 over x2 minus x1, which is delta y, change in the y, over change in the x, right? So let's look. What are we saying? We are saying that this is the change in y, this is the delta x. If m gets bigger, if m gets bigger than 1, what do we mean? Well, it means that y has gone up and x has gone down, doesn't it? It means that I'm getting steeper. So if m is bigger than 1, it gets steeper. All right? You're going to do a lot of these in class, but just in the logic, we've got 1 to 1. For those of you who do geography again, rise over run. So y equals x is going to have a delta x of 1 over a delta y of 1, right? So now if it gets, that's my 1 to 1, so 1 along, 1 up, right? That's quite steep. Now if the y gets bigger, it means that my line gets steeper. So if m, let's just change color, if m gets bigger, let's say, therefore, like that, m greater than 1. So it gets steeper. Well, then obviously m less than 1. So if the gradient is less than 1, it's flatter, right? Well, why do we have to know this? Well, because they're going to ask you some theory questions about it. But the main thing is you can check your work. If you're looking at it and you see that the gradient of something is a half and your line is standing up like that, then you know that there's something wrong somewhere. You've probably interchanged an x and a y or something. But it's just a way of checking where we are in the process, right? Okay, now let's just have a look what happens. Let's have a look at the effect. Sorry, let me just go back. Started with black, that's the best. The effect of C. Some textbooks do use y is equal to ax plus q. Please note that is the same as mx plus c. C and q are the same thing. I should have said that earlier, but we've said it now. Okay, so what happens with c? Well, let's just think. Let's go back to a standard graph, all right? And just, I'm not even going to use mathematics to do it. We're just going to ask the question. We said that our standard graph over there is y equals x. And just for safety's sake, let's just draw in y equals minus x over there, shall we? Those are our two graphs, standards. So that is y is equal to 1x plus c, right? Now let's just take a point here and we say, okay, we know that it goes through the point, well, let's just take this one here. It goes through the point 3, let's say it goes through the point 3, 3, right? So if x is 3, okay, y is 3. So 3 must equal 3 plus c. Therefore, c is equal to 0. The x-intercept is 0. So if we now go along and we say that, let's say c goes upwards, what are we doing to the graph? Well, we are moving the c-intercept upwards, aren't we? So the graph now moves up by c. So we would say, oh, hang on, it was 0. Now it cuts at 3. So that's y is equal to 1x plus 3. So the effect of the c value is to move the graph up. essentially. That's what it's doing, right? We're moving the graph up. Now, let us have a look if we take the value of C and we say, let us say C goes down. Graph moves down. So if we take the red one, the graph is going like that. It's being pushed down. And if we take the black, the C positive, it's moved up. So the effective C is moving the graph up and moving the graph down, sliding it up, sliding it down. That's what we're doing with the effect of C. So the M is going to indicate how steep it is, and the C is going to be shifting it up and down. All right? In essence, a very simple concept, isn't it? All right? Well, let's just have a look and say, well, okay, we've been able to move a graph up, we've been able to move a graph down, okay? So what are we going to do? We're going to say, right, okay, when we look at these when we look at these graphs, we're going to start the process of sketching them now. We're going to say, okay, what are we given? First of all, don't forget they could give you a graph. Let us say they give us a graph like this. All right? They give a graph there, and we say that is the point 0 and 4, and this is the point over here of -2 and 0. Sketch the graph, or what is the equation of the line? Okay? Well, of the straight line joining those points. Well, first of all, we say, okay, given, they've told us it is a straight line. That's what they've told us straight off, right? So, therefore, its standard form is y is equal to mx plus c. Then you look and see, hang on, but in this case, look, they've told us that is point C. So I can then say y is going to be equal to mx plus 4, because I know it goes through the y-axis at 4, right? Then I can say, there. Now we know it's y equals mx plus 4. How do we find m? Well, you are given two coordinates with x and y's. There you go. You know that it goes through -2 and 0. Therefore, you can say to yourself, okay, let me try and see, can I work out m? M is equal to y2 minus y1 over x2 minus x1. At this point, you go and you take your pencil and you say, I'm going to call you over here x1, y1, x2, y2, and it doesn't matter, you know it makes no difference which way around you do it. So we say y2 minus y1 is 4 minus 0, and x2 minus x1 is 0 minus minus 2 is 2 is 2. Therefore, the line here is y is equal to m is 2x plus 4. Done. Right? The straight lines are very easy. They're not a difficult section of the work to deal with, okay? Right. Now, what I'm going to do is now I'm going to just have a look at one. Let's just say we've got here, all right, of sketching graphs. Right? Okay, that's going to be the parabola. So what I'm going to do is I'm going to leave on, and now I'm going to move on to the parabola. Just before I go, just to finish off this piece, just let me just say something here. Okay. What they often do is they say, let us say they tell us y is equal to minus 3x plus 5. What would the equation be? So they say, what is the equation if we move the graph down by 3 units? What are we doing? We're saying that we've got a graph there and it's minus 3x, so it's that way. We are saying we are moving it down. Therefore, that means we've got a minus 3 movement. Right? So what are we doing? We are taking it down. So therefore it affects the Q. Minus 3x plus 5 minus 3 is minus 3x plus 2. So essentially the graph went from cutting over there at 5, now it cuts at 2. And the graph stays parallel. Parallel means that M is the same. The gradients of parallel lines is the same. Okay, remember that? Remember also that if I take them and I say the gradient of this is 1, the gradient of the line at perpendicular is minus 1. Because the M of the one times the M of the other must equal minus 1. Okay, we'll carry on with more of these in the next session where we're going to start looking at parabolas. Okay, please, the straight line is actually quite a simple one. Master the thing of the x and the y's and manipulating the equation, and you're fine. Okay, because the rest all follow the same pattern of the process is the same for each one. Cheers, I'll see you in the next session. Thanks for watching. Bye.